Hey everybody, so today I want to quickly show you how we can calculate normal distribution probabilities by using the TI-84s. So far we've been just using table A and finding z-scores and looking up our z-scores in table A, which is completely fine. I actually prefer you do it that way, but this is an alternative method that we could do with the calculators. So let's take a look at this scenario. Let's say we have test scores that are normally distributed with mean population mean mu is equal to 85 and population standard deviation is equal to 4.2. So they want to know approximately what proportion of students scored less than a 78. So I still like the picture because it helps you come up with what to do with the calculator. Typically we would find the z-score, look the z-score up in table A. So here's what we want to do. We actually want to use the normal CDF function in our calculator, which can be found if you look right above the vars button here. There is in blue DISTR distribution. So that's what we want to do. We want to hit second vars, which takes us to all of our distributions, and we want the second choice, which is normal CDF. We are never going to use normal PDF. We'll use normal CDF and inverse norm. So we're going to do normal CDF, and then what they want is four things. They want a lower bound, an upper bound, mean, and standard deviation. Okay, the picture is what helps you come up with the lower bound and the upper bounds. Okay, lower is what's the lowest number shaded, which technically this curve doesn't stop anywhere, it goes on forever. So what I always do is I just pick a really, really negative number, like negative 9,999. And then my upper bound would be the highest number that's shaded in, which is at 78 for this particular question. Okay, then your mean is 85, and your standard deviation is 4.2. And we hit paste, and then we would hit enter again, and we get our answer of 0.0478. Okay, which actually is the correct answer. Now, here's the bad news. If you do want to use this method on the AP exam, this right here, what I have highlighted, is what you'd actually have to write out with paper and pencil. You can't just calculate and say, hey, I did this in the calculator. They want to see what you set up as your lower bound, your upper bound, your mean, and your standard deviation. Okay, number two. Same idea, approximately what proportion of students scored higher than a 95. So here's my picture. I could go in my calculator, second, distributions, go back to normal CDF, and now I just need to adjust my bounds. The mean and the standard deviation will stay the same, but my lower bound is the lowest value shaded, which here is 95. And my upper bound technically goes on forever, so I'm going to pick something that's really, really, really large, like 9,999. Leave mean the same, leave standard deviation the same. Hit enter again, and we get an answer of 0.0086. Okay, so a very small percentage of the students are going to score higher than 95, almost like a little bit less than 1%. Okay, once again, if you want to do that on the calculator, you have to write out in pencil normal CDF, lower equals 95, upper equals 9,999, mean is 85, standard deviation is 4.2. Okay, what if, now here's where I think the calculator is nice. So what if they want to know what proportion of students score between two scores? Typically we'd find two z-scores and subtract the areas from table A, which is a decent amount of work, still very doable. But on the calculator, we can do this all in one step. Normal CDF, my lower bound would be 80, my upper bound would be 89, mean and standard deviation are still 85 and 4.2. We hit enter, and we get 0.7126. Okay, so that is pretty quick when you're doing that, which is nice. Okay, but once again, make sure you're writing out normal CDF and you have all this information here. And then the last type of problem is an inverse norm. So they said what test scores would be in the lower 10% of the class. So typically we draw our picture. We have 0.10 down here. We have to find the z-score in table A that goes with 0.10. Then we can use our z-score formula and use algebra to figure out what the value of interest is, or x is. On the calculator, we can just go right to second distributions and go down to inverse norm. If I hit enter on inverse norm, it only asks for three things. It asks for the area, which is always going to be the area to the left. So it's always going to be wherever we're at down. Because that's the way like table A is set up. And then we can type in, it's set up for 0 and 1. Remember, that's the mean and the standard deviation or z-scores. So if we actually hit enter on this, it's going to give us our z-score. The z-score is negative 1.28. But we don't want the z-score, we want the test score. So if you go back into that, all we have to do differently is change mu and standard deviation to our test score, mu and standard deviation. Hit enter, and we get an answer of 79.62. Okay, so a test score of 79.62 would be at the 10th percentile. They want to know what scores would be in the lower 10%, so anything at 79.62 or less. Okay, and that's how you use normal CDF and inverse norm on the TI-84.